Solve the system and illustrate the solution by graphing. To solve this, I'm going to use elimination. I'm going to match the coefficients on the x's. So the least common multiple of 3 and 4 is 12. So I'm going to multiply this first equation by 4 and the second equation by 3, and that's going to give me a 12 in front of both of those x's. So the first equation turns into 12x minus 24y equals 48. And then multiplying the second equation by 3, we get 12x minus 24y equals 48. Now these are identical. So if we could just subtract these, all we're going to get is 0 equals 0. Now obviously 0 equals 0 is just a true statement no matter what. What this means is that there's actually an infinite number of solutions. Now we can't just say there's an infinite number of solutions. We need to actually specify what the forms of those solutions are. Because just because there's an infinite number of solutions doesn't mean any numbers work. So what we usually do is just solve for one of our variables in terms of the other. So if I solve for x right here, I have 3x equals 6y plus 12, and then divide by 3, and I get x equals 2y plus 4. And so that's my solution. Anything on that line is a solution. And sometimes what we'll do is we'll use what's called a parameter, and we'll say, well, a y can be anything. I'm going to call it t, and that's what's called the parameter. And then x is equal to 2 times y, which is t, and then plus 4. And so this would then be how we write our solution, or as an ordered pair, 2t plus 4 comma t. And so every solution of this system of equations is of this form. Now, since t can be anything, there's an infinite number of solutions, but the solutions still have to be in this form. Now, let's go ahead and look at the graph. And we see that, well, both of these just ended up being this same line. And so every point on that line is then a solution to that system of equations.